Hello friends, welcome to a lecture on chemical engineering thermodynamics. Today we will be studying about application of Gibbs phase rule to multi-component VLE. I am Professor Arvind Prasad. Now Gibbs phase rule for a non-reacting mixture is F is equal to C minus P plus 2, where F is the degree of freedom, C is the components and P is the phases. Now let's apply this to a multi-component VLE. Now for a multi-component VLE, the variables are temperature, pressure, volume per unit mole or specific volume, specific internal energy, specific enthalpy, specific entropy, specific Helmholtz free energy, specific Gibbs free energy, and X size, that is the mole fraction of the components in the liquid phase, and Y i's, that is the mole fraction of component in the vapor phase. Now if we apply the Gibbs equation or Gibbs degree of freedom equation to such systems, we get F is equal to C minus P plus 2. The components are 2. We assume it as a binary mixture for simplicity now. So components will be 2 minus 2. The phases are 2. That is, we have a vapor phase and we have a liquid phase. And then it is plus 2 after this, and the result of this is 2. Now for a binary system, that is a two component system which has component 1 and 2, at equilibrium, if temperature and x1, that is, let us say the concentration of component 1 in the liquid phase is fixed, then all other variables are fixed. What does this exactly mean? Well, if x1 is fixed, that is, the concentration of component 1 in the liquid phase is fixed, it goes without saying that x2 is also fixed because x1 plus x2 is equal to 1. Well, if the temperature is fixed, then we can say that y1 and y2 also are fixed. And the pressure is fixed, the internal energy of the vapor and the liquid phase is fixed, the enthalpy of both the phases is fixed, so is the entropy, and so is the Gibbs free energy. Also, the specific volumes of both the phases are fixed. Now, such a conclusion can be used to understand systems. Now, let's take an example. Let's take the system of distillation. Now, let's apply this rule to distillation. What we have in the batch distillation unit, for simplicity's sake, of course, is a binary system which is being distilled. Now, component 1 is the highly volatile component. So obviously when we heat this distillation unit, component 1 is going to have greater concentration in the vapor phase. We are going to condense it and put it in the distillate receiver. As this distillation proceeds, the concentration of component 1 is going to reduce. Why? Because component 1 vaporizes quickly. It vaporizes more quick than the component 2 because it is more volatile than component 2, and therefore it is distilled quickly. So its concentration will reduce as the time goes by. Now the consequence of applying the Gibbs degree of freedom equation to this is that if the pressure is fixed, that is, the pressure of distillation is fixed, for any concentration, using the degree of freedom rule, we can conclude that the temperature of the still will also be fixed or unique. So for every unique concentration, we are going to have a unique boiling temperature in the still. Of course, this is for distillation at constant pressure. Most of the distillations, if not most, all of the distillations occur at constant pressure in batch distillation units. Now, how does this apply in making logical conclusions? If we have a temperature indicator in the reaction, or not in the reaction, in the batch distillation still, then by knowing the temperature, we can know what is the concentration of X1 in the still. Now this will help us in starting and ending the distillation process. How? At the beginning of the distillation process, we know that the temperature will be T1 because X1 is high. Now, as the distillation goes, the temperature is going to increase. Now, this is the starting concentration and this is the starting temperature. So, as the distillation proceeds and the concentration of X1 reduces, the temperature in the still goes up. Now, when we reach the desired concentration in the still, the desired temperature is also reached. So, if the desired temperature in the still is red and known, we can stop the distillation. Therefore, this allows us to control the distillation process. In short, if we know the still temperature, by knowing the still temperature, we can control the distillation process. That is, we can decide when the distillation process should stop. Why? Because the temperature is related to the bottom concentration. Hope you have understood, guys. Please like and subscribe my videos. And if you have any other requests, do let me know. For now, have a great day.